Okay, so now today we'll discuss about derivatives and continuity. So let's start with what is derivative and how we can attain the continuity in derivatives. So now that we can graph a derivative, let's examine the behavior of graph. First, we consider the relationship between differentiability and the continuity. Okay, so this theorem states that let f of x be a function of a, b in its domain. So if f of x is differentiable at a, then a is continuous at a. This means that, let us say that f of x is a function, okay, and a is basically domain. A might be 1, 2, 3 or anything. Okay, so if a is the domain and there's a solution for a, let's say I put x equals to 1, so my function of 1 equals to, let's say, -5. So it will be, say that f is continuous at a. So this means that continuity of my function. So moving towards the next thing. Now there's a proof of this. Let us say that we have a point of what f of x basically is differentiable at a. So we can take a point, f of a and make a derivative. So by using equation 3.14 as I described earlier, I have to apply the limit what x approaches to a, because a is my domain. Then f of x is my original function, minus f of a divided by x minus a. Okay, so we have to find the value of fx at a, and then we have to differentiate it. Okay, so we want to show that f of fx is continuous at a, because this is the motto of my derivation, that whether my value or the variable a is continuous at my function value or not. So I have to apply the limit x approaches to a, and the f of x, my answer will be f of a. Okay, so this will be my ultimate goal, to find the value of this one. So I have to find the limit. First, I have to put limit x approaches to a with a function value f of x. Okay, so as we know that this value equals to limit x approaches to a, and then there is a f of x. Now in this step I have to subtract and add f of a. Why adding? Because to find the solution. Okay, so minus f of a and plus f of a has no resultant effect on my system, so I have to add minus f of a plus f of a in the system. Okay, so now we have to find the differential. This is the differential, that fx minus fa. So I apply the limit on this variable. So how to find it? So this limit will be, just give me 1 sec. Okay, so this is that is fx minus f of a. As we know that this value equals to fx minus fa divided by x minus a, then I have to multiply with x minus a. Why? Now this is the point, that limit x approaches to a. Again, for the first step, this is the first step. Okay, so it will be, first step I have to f of x, I have to subtract and minus add the value of f of a. Okay, so in the next step, in the second step, I have to multiply and divide x minus a with this function, that is f of x minus f of a. So in the next step, we will say that multiply and divide the value of x minus a, here it is divided, and also it is multiplied, so there will be no resultant effect on the system, plus a. Okay, so this is This is my second step in which I added the value of f of a and f of x in my system. Okay, so this is the first condition to do. Okay, now this value, I have to differentiate this value and this value. Now I have to apply all the limits. So first I have to apply limit on this function. So this function will be written as this one, fx minus f of a divided by x minus a, then applying the limit x minus a, then applying the limit on f of a. Now, when I apply the limit, x approaches to a. So what will be the my result? I have to write here the result for this system. Okay. For this system, I know that this is the derivative of a, f derivative a. Okay, so I have to put that my first value equals to f derivative a, which will be given in my equation number 1. Now for second value, when I apply a, that when I apply a here, so a minus a, the value is what? Value is 0. Then plus, now applying f, x approaches to a, so it will be the value what? Xa. Because there is no resultant change, this is the value. This function have already the value of f of a. Okay, so this value will be 0 multiplied by this equals to 0 plus f of a. So my value equals to f of a. This shows that my limit x approaches to a as okay, x approaches to a will be equals to f of a. Okay, so again, this will be my conclusion that limit x approaches to a with a function f of x, it will be equals to f of a. Okay, so again, now finding the derivative at 0. Let us say it is 0, so that x approaches to 0. So f of x minus f of a. So f of 0 will be my 0 value, and x minus 0 will be, this value will be 0. So my limit will be x bar and x. So how to find it? So the value for negative value, it will be negative, and for positive, it is positive. What will be? Because this is the value of absolute. Absolute always has two outputs, whether it will be positive or negative. So for absolute system, my graph will be like that. For a given value, I have a respective positive value as well as negative value. So this is the case of absolute. This is the graph basically of absolute. So absolute has, already I said that absolute has two values, whether it will be positive or negative. This is same. Let us say that I have to apply the value of function will be f of x will be the cube root of x. So it will be cube root of x minus 0. This will be equals to positive infinity. So this will be, my graph will be like that. Okay. So this is general elaboration, and the graph for this system will be like that. This is the general basically proof that how to find different values. Let us move towards the example. Moving towards the example, we have to discuss about summary that we observe that if a function is not continuous, it cannot be differentiable. As I described earlier, that for a continuous system, it must have a value, and this value will be written as a continuous function. So if it does not differentiate, so my function will not be continuous. Since every differentiable function must be continuous, however, if a function is continuous, it may still fail to be differentiable. This means that if function is continuous, so there will be a chance that the value may be infinity, that the value may be zero, or that the value may have under root values. So there's a chance that whether my points are continuous, but my function will not be differentiable. Okay, so in case of f of x equals to absolute, fail to be differentiable at 0 because the limit of slopes of the tangent lines on the left and right were not the same. So as I described earlier, for absolute values, my graph have two values. Two values mean the same value in positive and same value in the negative. But at 0, it will not differentiate because 0 doesn't have any positive or negative value. So you can say that it may be differentiable at 1, at 2, 3, 4, and so on. Okay. For cube root, a function fails to differentiable at a point where there is a vertical tangent line. Okay. So vertical, what is meant by vertical tangent line? Vertical tangent line is like that, so it will not differentiable that this one, as it is a cube. So cube must have a curve. It is not differentiable at slope. So slope is for linear system, as it is cube root, so it must have a curve, so it does not differentiate at a vertical tangent line. And this function f of x with sign values may fail to differentiable at a point is in more complicated ways. Okay, so this is the complicated function. So we have to differentiate one by one as I differentiate in the proof. Okay, so this is the general four aspects of a continuous derivative functions. So let's move to the example. In the example, this is basically the part or a type of this type of function. Okay, so this is the complex type of function. So how we can solve a complex type of function? So for complex type of function, this will be solved like this one. This is the basically by taking the limit, then multiply, divide, and all of this. Okay, yes, a toy company wants to design a truck for a toy car that starts out along a parabolic curve and then converts to a straight line. That it starts with a parabolic curve like this one from this point to till 10, and then it stays at constant straight line. For the function, this is the first function when x is less than minus 10. So what is this value? This value is when x is less than minus 10, that it is in this part. And for x is greater than equal to minus 10, I have taken this part. So these two functions are given. Again, I have to describe that. First is this limit till infinity. Okay, so and second is this limit. Okay, the function must be both continuous at and differentiable at minus 10. Okay, now my point will be this one, minus 10. So my function will be continuous and differentiable at minus 10 value. Find the value of b, c that makes the function continuous. Now what is b and what is c? This is the value. This is the b and c. I have to find these values. Okay, so let's move towards the solution of this numerical. Okay, so for this one, we have to know that my function value will be basically continuous at minus 10. So it will be written as that my function or limit. Okay, so this will be written as limit x approaches to negative 10, so 10 and negative sign will be upward. Okay, always if there is positive, so I have to add the sign upward, not here. Okay, if I, this is the wrong way to elaborate in limits. Okay, so I have to elaborate here and then putting the value of function f of x. So this means that putting the value of x equals to minus 10, so my value will be function of value at x equals to minus 10. Okay, so for the first system, my function is given. I have to write here. Just give me 1 second. I have to write these two functions. So my first function will be f of x equals to 1 upon 10x squared plus bx plus c. And second is f of f equals to minus 1 upon 4 plus 1 upon 4x plus 5 upon 2. Okay, now these are basically two values. Okay, so moving towards this one. Now applying the value of what x equals to minus 10, because we have to find whether this function is continuous at minus 10 or not. So my value will be function that limit. First I have to find limit x approaches to what, minus 10, so it will be minus 10 here of function f of x, and which will be equals to 1 upon 10. Now I have to find the value of function of minus 10, so putting the x value minus 10, so it will be minus 10 square plus b, x values again minus 10 plus c. So this function limit equals to 10 minus 10b plus c. So this is the value of limit function when applying 10x equals to minus 10. Okay, so as and f equals to minus 10 equals to 5. So for what function? So this function, by applying here f of x equals to minus 1 upon 4. So for this function, minus 1 upon 4 into minus 10 plus 5 upon 2. So this would be minus will be positive, and the answer will be 10 upon 2. So it will be 5 upon 2. So it will be minus will be. So this will be the value at certain point. Okay. So function f inverse, so the f of negative 10 equals to what system? This is the value. Okay, so this is the value. Now taking the LCM, this LCM will be 4, then it will be 4 times, and then it will be 10 plus 10 plus 10, 20 upon 4. So it will be 4 and 5. So this value is 5. So from these points, or the value equals to minus 10. Okay. So we should know that this function 10. Now, sorry, there are two. Sorry again. F of minus 10, in applying the first condition, it will equals to 10 minus 10b plus c, and f equals to minus 10 equals to 5 from the second equation. Now comparing left hand side, right hand side for both equations, so it will be written as 10 minus 10b. Why are we comparing? Because left hand side for both equations is the same. Okay, plus c equals to 5. So for this, it will be written as minus 10b plus c equals to 5 minus 10. So it will be minus 10b plus c equals to minus 5. So it will be c equals to 10b minus 5. So this is the value of c. This is the step how to find the value of c from this. Okay. Now applying the limit, or the applying limit function as for function, I have to know that the function derivative. Okay, now our function derivative will be equal to limit x approaches to what, minus 10, with the f of x minus f of what, minus 10 divided by x, okay, minus of minus 10, because it is x minus 8. So it will be limit of x approaches to minus 10 with f of x minus f of minus 10 divided by minus will be positive, so it will be x plus 10. So this is the x plus 10. Okay, so now I have to differentiate it. So for differentiation, this will be equals to f of x. What is the value of f of x? F of x equals to 1 upon 10x square plus bx plus 5. So this is the value which is given to us. This is the value. Okay, this value is given. Okay, so this is the value which is given. So now putting this value, so this is now function of minus 10. So what is the value by applying the function minus 10? My value equals to 5. Okay, so put this value here divided by x plus 10. Okay, now for c, we find the value of c. So putting c here, so c will be 10b minus 5. Okay, so now after this I have to take the LCM. So from LCM it will be equal to x square minus 100x plus 10bx plus 100b divided by 10 into x plus 10. Okay, so again from this I have to make the factors. So the factors will be x plus 10 into x minus 10 plus 10 divided by 10 into x plus b. X plus b will be 100. Sorry, it will be 10. So x plus 10 divided by this one. So why this x plus 10 and this x plus 10 will be cancelled out. So it will be here and here. So then this will be x into 10 minus this one divided by 10. Okay, so for this, now applying the value x equals to minus 10. So it will be limit x approaches to minus 10, x minus 10 plus 10b divided by 10. So for this equation, my x value equals to minus 10. Okay, so this will be minus 20 plus 10b divided by 10. So it will be minus 2 plus b or b minus 2, which will be written here, b minus 2. Okay, so this is the value of p for my system. Now applying for the second system. Now as this is x is less than minus 10, so minus 10, this value will be negative and this value greater than equals to will be positive. Okay, so this value, as this value is always less than 0 or always in negative, and this value will be after 0, it will be positive. So this value will be positive function and this value will be negative function. Okay, so for negative function, this will be written as this will be written as minus 1 upon 4x 5 upon 2 minus 5. This value is minus 5 divided by x. Again, this is we have to write here. Just give me 1 second. My limit is basically x approaches to minus 10. So minus 10 will be negative. I have to negative here or positive. Okay, so I have to write that limit of function minus 10 with a plus here. Okay, So this function will be written as limit x approaches to negative 10 with a positive domain. So it will be f of x minus f of negative 10 divided by x minus, and the function value is minus 10. So this will be f of x minus f of negative 10 divided by x plus 10. 10. So this will be minus 1 upon 4x plus 5 upon 2 minus 5 divided by this one. So it will be 4, okay, minus 1 plus 10 minus 20 divided by x plus 10. Okay, so yes, this is the x minus 1, so this minus 1x, so it will be 4 with minus x minus 10 into x plus 10, taking negative common, so x plus 10 divided by 4 into x plus 10. So this x plus 10 and x plus 10 will be cancelled out. So my value will be minus 1 upon 4 for the system. Okay. So this value is what? This value shows that my function, two function values, I have to compare it. That limit of function x minus 10 minus will be equals to limit of sorry, limit of function minus 10 positive. This value equals to b minus 2, and this value equals to minus 1 upon 4. So from here b equals to minus 4 plus 2. So this value will equals to 7 upon 4. As c equals to what? For c, we have to find, we have to go previously. This is the value of c. C equals to 10b minus 5. So it will be 10b minus 5. So it will be 10 into 7 upon 4 minus 5. So this will be equal to 25 upon 2. Okay, so this is the end of this lecture. So we will start with the higher order derivatives in the next lecture.